All right, so we were talking about photovoltaics and how in the world do you get? I mean, you've seen them, right? We've all seen them. It looks like it's glass. How in the world do you get glass to absorb energy and produce electrons? So the flow of electrons is what electricity is. And so the question is, how do you get silicon, glass, to absorb the energy from a photon and have it move out into the power grid? Well, it's not just glass. They call it doping. They call it doping of the glass. And so glass is made of silicon, and you have all these layers with different additives. So doping is where you add 1 part per million of something else. And so on the top layer, the layer that is going to be closest to the photons that are coming down, you're going to add arsenic. And arsenic has an extra electron. And so this electron can easily be excited to a higher energy state so that it can leave the arsenic. So the arsenic gives up an electron, and where does it go? It goes down to the next layer down, where we have doped with something that needs an electron. So arsenic, the electron jumps to gallium, and so on. And so you get this flow of electrons down through the glass and out into the power grid. That's how we do it. We have N-type and P-type layers, and this is where that easily gives up an electron, and the next one easily absorbs an electron. When we hear about photovoltaics, we hear about how they're becoming more and more efficient. Well, this is the way you increase efficiency is you make these layers very thin, and you have more and more of them. And so, as long as you're exposed to light, you can then be adding electrons to the power grid and producing electricity with these things. First of all, what are the problems with doing this? The problems with doing this is, even though silicon is cheap, you got to purify it. Remember chapter 1, we were talking about it's very hard. You have to get that, 9N or 12N purity, really pure stuff. And then, of course, we have this efficiency question. And so in the past, they've found if by adding layers you get it becomes more and more efficient. By multiple layers, I'm trying to see here if I look in through my notes. We've gotten the efficiency up by adding more and more layers. To like if you have 36 layers of this stuff, you can get your efficiency up to 72%. But what happens when it's not easy to do this. So what happens in order to get this high efficiency photovoltaic, it costs a lot of money. So again, economics always come into this process. Okay, let me stop right here, and I'll be back on the next one.